Yes, good evening, everybody. I hope I'm audible to you all. Am I audible to you all? I can be heard, right? And also that the screen is visible to you. So, a picture that you see here is that of a drone. You must have realized it. This is a fixed winged drone. Okay. So, it doesn't have rotors, mm, which means that there are different types of drones and they are fixed with a specific kind of a sensor that is capable of performing different tasks or taking pictures in by taking pictures in different sensitivity and also different sensors. For example, there could be some optical sensors, there could be some radar sensors, or there could be lidar sensors. There could also be some synthetic aperture radar sensors. So all these things are possible. So today we are discussing yet another growing area within geospatial sciences, which is UAVs. What it stands for is unmanned aerial vehicles. That means they are aerial vehicles. They are carrying something. They are carrying some passenger, and that passenger is the sensor. In simple terms, it is a camera, and that particular vehicle is unmanned because otherwise there will be a pilot flying that particular aerial vehicle around, maybe an aircraft if you think of. But this drone or what we call UAVs, they are unmanned. So UAV stands for unmanned aerial vehicles. Okay. So commonly we will, for now, we will simply call them drones because that is one such word which we are very well familiar with. So what these drones have done is that they have transformed the way in which this geospatial data is collected. So earlier, once these aerial photographs, capturing aerial photographs, no, it required very expensive aircraft surveys, or maybe waiting for satellite to come over that particular area and then capture a photograph of it. But now it has been done very quickly because of these drones. So we are doing it very accurately, quickly, and then also it is cost efficient. Rather than going for a satellite, we have a specific purpose. Rather than going for a satellite, because such a satellite is not made by any agency as of now, we will go for flying a drone and collecting data as we require, as and when we require, and in whatever um, resolution or whatever spectral resolution we wanted. So today we are talking about these UAVs. There will be one more topic that we will leave behind, but I'm thinking that I will be recording that particular class as well today, and it will be shared with you as a recorded session. This there are certain other things that are lined up, and I'm not able to stretch this particular course any further. And one particular class we will have it in a recorded session. You can have it, you can watch it at your convenience. One more unit test that is pertaining to unit 9 will be shared with you by tomorrow. Complete your assignments by somewhere on 11th. I think I told you by 11th or 12th, something like that. You complete it by that Saturday, so that by Monday we will be able to send you the certificates. Okay. We will be sharing it through email, or we might share a drive link with you from where you can download your certificates. Whoever completes the assignments, that is the MCQs, by that Sunday at least, okay, by that Sunday or by that Saturday preferably, we will give you a course completion certificate. Those of you who did not submit all the assignments will get a course participation certificate. So make sure that you complete all the assignments, that is all 9 unit tests, and be on a safer side. So a UAV that we are talking about, or this unmanned aerial vehicle that we are talking about, it is also an aircraft, but it operates without a human pilot who is on board. Okay, so there is no pilot who is on board. It can be controlled very remotely. So you don't have, because there is no pilot who is sitting inside, somebody has to control it. And who controls it? It is the somebody who is not sitting inside, maybe remotely is available, and that operator is moving this particular drone around. or that it is at least programmed. So if there is no controller, there is no man present there, then at least there is a controller program which will help this particular UAV to fly very autonomously, okay, independently, along a flight path that is predefined. Okay, so let me, where is it? Yeah. So what you see is there is a drone that will follow this green line that has been already planned for it. Okay. So these drones, they are capable of flying not just by a person who is remotely controlling it, but you can predefine what is the flight path that it is going to take. That is the best thing about these um, drones. Okay, so nobody needs to monitor it and things like that. It does its own, it does the work on its own once it is given to it. So this UAVs, no, as I told you, that they will be carrying a sensor on board. You will call that a camera as well. These drones are also GPS enabled, which means that it knows which latitude, longitudes it is following. And sometimes it also carries very advanced sensors like that of LiDAR. LiDAR, for example, LiDAR stands for light detection and ranging. So it has a source. The uh, drone has its own source. The sensor has its own source, sends some light towards the surface, and that light comes back and is sensed by the sensor. And through this, it realizes what is the distance of that point from where there is reflection happening and being sensed at the sensor on board that particular drone. Okay, that is called LiDAR. It helps you in understanding the topography and things like that. It also penetrates through the vegetation cover. So often it is used in identifying mm, bottom topography in some forested areas and things like that. Now, specifically in remote sensing, these drones will serve very well when you want to acquire some information, when you want to acquire some information at a low ground level. That means you don't want to take help of a satellite far in space. You want to collect high resolution imageries, and for that you want to fly, you want the sensor to fly low, at low altitude, because of which you will get more crisper information, more clearer, more high resolution information. That is why we are talking about high resolution mapping as well today. So these platforms are capable of collecting very detailed, extremely detailed information about whatever feature that you are planning to study. Okay. Now, if you want to understand the significance of these UAVs, no, you will have to compare how this traditional satellite data and this remote sensing, that is UAVs, both of them are different from one another. For example, if I was to talk about satellite imageries, no doubt that they are providing extensive spatial coverage. That means it is covering a huge area at one go, and at regular interval also it is doing it. That means after every 16th day, Lancet is capturing one image. After every fifth day, Sentinel is capturing one image. But when we are talking about these UAVs, these drones, when we are talking about, they may not be able to cover a huge area like how satellites do, but they are able to capture imageries with resolution as fine as that of very few centimeters, maybe just 5 centimeter. Okay, at 5 centimeter level, it is able to collect very, very accurate data. And that is one very big benefit of these UAVs or drones. I will simply call them drones henceforth. Okay. So when a drone is flying at a lower altitude, it is closer to the object, because of which it is able to see more and more detail. For example, let's say you are on a hill station and you're looking at many mountains in front of you. But there is one mountain that is very far. It appears to be smooth to you as compared to that of a mountain which is closer. The one which is closer, you can see independent trees, so you feel that mountain is rough because you are able to see the details. But then if a mountain is very far, then you will see that it looks very smooth, like as if it's just a creeper that is covering the entire mountain. But there are, if as you come closer to that mountain, you will start realizing that there are many different trees there as well. Okay, I hope this is making sense to you. Now, if you have any query, please drop it in the chat box. We will talk about it. We have enough time. Now, because of this ability, that is very high resolution of these drone imageries, um, these UAVs have become indispensable, and because of which they are very widely used in modern geospatial applications as well. Any kind of study that you are doing with satellite data, you can do it with this drone imageries as well. That is the best thing about it. So high resolution mapping here, when I say, I am trying to say that creating such a spatial data sets that will capture very fine details. Okay, that is what I mean when I say high resolution. Low resolution means you see minimal details, or some details are just not there. You have not been able to capture some of the details. High resolution means you're capturing more details, more crispier information. Okay, so these high resolution maps will provide very accurate representations of the terrains, where there are up hills, down hills, where there are valleys. Um, Even at centimeter levels, it is able to do this. If you want to study infrastructure or vegetation, or if you want to study water bodies or any other surface features you want to study, then this high resolution imageries will give you best information, complete information, without leaving a lot of chunk of this information behind. Okay, so uh, when you want to capture any UAVs, any satellite data, we were talking about this flight path itself. So it begins with you deciding how this particular drone will fly. So you decide in what manner it is going to go, where from it will start, where it will stop. So you can plan its path. Okay, that happens before data collection. So the operator of this drone will identify which flight path this particular drone will take. And besides that, he will also decide on to what will be the height of this drone, at what height it will fly. You can see here that there is a height also in that particular image. I hope you are able to see the image, there is a height to that particular flight height is there. And then you also need to know have some overlap among the images. So an image that is captured here and the next image that is captured, in between that there has to be some area that has been overlap, that is captured by both these adjacent imageries. Okay, so overlap is also mandatory. Also, you have to decide the camera setting, for example, the shutter opening or the shutter close timing, and all that. You need to know how much of light you are taking in into the sensor, and all this you have to pre-plan. Uh, Once the drone starts flying, it will keep taking pictures with whatever setting that was available with it previously, unless and until you make any changes. And besides that, you would also want to know what is the ground sapling distance that you need to know. That means how what should be the distance between the two adjacent images. That means after every 1 second you want the next image to be taken, or at the second, or after 1 minute, that you have to decide. All these things are predefined. Then what this drone will do, it will take the planned route, and it will capture hundreds or even thousands of these images that you have decided. And these overlapping images are very important, because they will allow the software to reconstruct that entire landscape in 3 dimensional. Essentially, if you want to create a 3 dimensional model of it, what is the height of the canopy around a particular area for some site visit and things like that, then you would want to also consider how much of overlap should be there. Overlap has to be sufficient such that you are able to um, create a 3 dimensional model of that particular area that you have just imaged. Okay, so once these images are collected, you go through photogrammetric processing. That is, you have two pairs of images. You look at both of them simultaneously, because of which you are able to see you are able to perceive the third dimension. That is what we call photogrammetry. And we know that photogrammetry will help you in understanding, in getting the 3D perspective, because of which you know which tree is taller than others, which area is taller than other, which one is low lying area, and some terrain analysis also you can do. So you are basically doing something called orthomosaicing, which is very important. We were talking about orthorectification. I hope you remember this. We were talking about geometric corrections in pre-processing steps. That is where we were talking about ortho corrections, orthorectification, orthogeorectification, which means you are considering even the height differences. You are also considering the errors that are introduced because of differing height with respect to that of the sensor. Some areas are high elevated closer to the sensor, some areas are low lying, hence away from the sensor. Okay. Now, so they create something called DSM. You must have heard of digital elevation model. DE DEM. Them you must have heard of, digital elevation models. But these drones, the normal photographic drones or LiDAR drones, they give an output that is called DSM, digital surface model. That means the height of the plant will be taken up. Whereas what is DEM? DEM represents what is the elevation of that particular point. Then you also have DTM, that means digital terrain models. What exactly these terrains are? These are bare earth surface. What is the elevation of bare earth surface? When you scrape off all the built up area, when you scrape off all the vegetation, then what is the original height of that particular point? That when you measure using these drones or even during using satellites, then you call them DTM. So if you want, you can write it down somewhere. DTM, DEM, DSM. Digital surface models, digital elevation model, and digital terrain models. So these are the three different types of data pertaining to the elevation. Okay. Now, from these data set, that is DEM, DSM, DTM, you are able to make very highly accurate topographic maps. Okay. Why we require topographic maps? Because we want to maybe plan a new road. So to identify the best possible path, location for this road, or if we want to plan some dam, maybe some vented dam, we want to plan some tunnel. So which is the ideal location? So all these things will require this kind of data set: DTM, DSM, DEM, DEM, DSM, DTM. Okay. Now, besides that, we are also using it into forestry, because we want to know what is the canopy height, where essentially canopy height is more. We were talking about carbon accounting, where thicker the forest, more is the carbon stored. So there we were talking about these canopy height. So again, drones are used in understanding where the trees are taller, where they are mm, stout and things like that. Again, in urban planning also we are using it. We are mapping these buildings, roads, drainage systems. If you are planning for new drainage systems, which area should be prioritized, then understanding what is the status of any given infrastructure. All this will require high resolution imagery, which a satellite might not be able to provide you, but a drone is a wonderful choice. Also, you will see these municipal authorities are also using drones nowadays. Very rarely in India, but I believe PMC was also using drones in order to identify where all there are garbage that is collecting, illegal spots where people are just throwing garbage and things like that, or where there are these drainage systems clogged and things like that. Mumbai Municipal Council, Bombay Municipal Council was using these UAVs. They were also using thermal infrared cameras somewhere to identify some crime scenes. There was a murder somewhere in Western Ghats. somewhere along the borders of Zorlaghat very recently, I think some 4 or 5 days back, and thermal cameras were also used. That's what I heard in some news. And it has been used previously also. It's just happened very recently close by, so I'm mentioning it. So engineers will also use drones. Engineers are also using drones. Let me show you some good images rather than just showing you this. So see this, this is where coast is getting captured. So you see where exactly the waves are breaking. You are able to locate different outcrops that are present within the kind of forest also you are able to identify. Then have a look at this as well. So you are able to see that there are reefs here. In shallow water, there are reefs. We don't know what kind of reefs they are, okay? Coral reefs, or they are shallow outcrops with some uh, mussels and things like that that are growing. Beach rocks, what we call them. Then this is a road. It's just some entertainment. But here the river has some water hyacinth, and that is being planned to remove off. So such an imagery is taken of that particular river stretch. You see something like that here also. Then this is a lake that is shrinking. So you will see that the lake has a tides. It is connected to that of the sea around that. You will not get convinced that there is a sea behind, but you will have this PPT ultimately, and you will realize there is a sea behind. Okay, and this particular lake is hydrodynamically connected with that of the sea. So it shows you tidal fluctuations within the lake. You won't see surface connectivity between the sea and the lake, but uh, still the tidal effects are seen. Then here also some recreationary photography. This is a LiDAR image. So all these red portions that you see, these are the tallest regions. For example, this canopy, and then this power line. Then the ones which are green, these are the lower ones, and the blue ones are the water bodies. So there's a water body here, low-lying areas, even low lying somewhere here. There is the most low-lying. I wouldn't say that it is a river. Okay, I will reconsider that because this seems to be a road. So this is low-lying, and then we don't know. This must be not captured or something like that. This area is not captured. This area is not captured. So this is a lidar image. You see some predefined paths. For example, this person is planning to only capture this particular area. So the planned flight path you see in similar manner. It is not exceeding that of the boundary. It's not going out of the boundary that is planned. So it is only surveying this area that he requires. Let me just display this particular picture for you. So these engineers we were talking about, in engineers you will see they are extensively using drones. They are monitoring construction progresses, or they are calculating how much of soil volume, or what we say earthwork volume is required. How much of soil is required, concrete is required in order to fill up a valley so that the road becomes elevated and things like that. All that they are measuring. They're also inspecting a given structure after its construction, or maybe they have been given some task of identifying what is the strength of this bridge. So you monitor it, you take good pictures of it, make a 3D model of it, and see where there are weak links in that particular, maybe a pillar of a dam, or beams of building and things like that. So all for all that, engineers are using this. And using these drones, no, it will significantly reduce their field visit time. They don't have to go to the field. They can just send a drone there and analyze the data, capture the data, and give their report, whatever that is. Okay. So then again, what are the other things that I want to mention you? Also, these drones are used in real-time monitoring of floods or landslide or earthquakes, also cyclones. Not really cyclones, but after the cyclone has passed, then, because otherwise drone will just get deviated from its predefined path because of the wind that is blowing and things like that. So one thing that we understand is that UAVs are capable of capturing very high resolution images very quickly also. Whenever you want, you don't have to wait for the satellite to pass over that area. You're getting higher resolution data, more detailed data also you're getting, and it is cost efficient also. You can capture data set at whatever sensitivity that you want and at what sensor limit you want. So all this you can plan, everything you can plan. Okay. And you are at a better um, on a better side to assess the kind of damage that you are intending to, or if you're trying to go to some place which is otherwise inaccessible, there's no road there, and you're afraid of going there because the terrain is difficult, or it's lush green, very dense forest, many wildlife, things like that. So you can send a drone there. You don't have to be worried about that these areas are inaccessible and things like that. So uh, specifically, if I was to talk about my field, that is coastal dynamics, then you will see drones being used to identify areas which are actively undergoing coastal erosion, such that we are able to see, okay, this is the area where coast is eroding, beach sand is eroding, and recreational value of that particular beach is also going down, or it is about to erode away the coastal property. Maybe somebody's house is there, maybe a highway is there, it's getting eroded, so that risk is there. So we can plan a feature there, maybe a sea wall, maybe a groin, maybe a breakwater, or things like that. So all that can be done, or all that is done through these drone surveys in essentially coastal imaging. No, a little bit about LiDAR. No, this image that you are seeing, it's a LiDAR image. What it does is that a LiDAR system, no, a LiDAR sensor, it will emit laser pulses. That means it's not a continuous pulse that is sent towards the object that is lying on the planet surface, but it is a pulse. So there will be a pulse of, or there will be a beam or a pulse of this light, laser is a light that will be sent towards the surface, towards the object, and its return time is measured. Okay, so now it is sent, and then it will come back and sense at the sensor. So what is the time that it has taken? Longer it has taken, farther away that particular object is. So it helps us in a detailed three-dimensional mapping. So this is what you see in that particular picture as well. It's a three-dimensional picture of everything. The plants that are present there, the buildings that are present there, the power supply lines which are there, all these things. LiDAR also is capable of, by the way, scraping of vegetation layer completely. So you see only the soil. Okay. There was a documentary that I saw very recently wherein some archaeological sites were being identified along Sundarban areas, where there were some square shaped compound walls that were identified. Otherwise, people find it very difficult to go in such areas. These are deeper Sundarban forests, but using these LiDAR sensors, that entire vegetation surface can be taken off such that these square shaped areas, square shaped some compound walls that were definitely not built now. So they are archaeological sites. They were identified. Not just there, I think the same person was looking for some similar things somewhere in Scottish Highlands as well. So that person goes around with his LiDAR sensor and keeps identifying some archaeological sites and things like that. Many of you might have also seen it if you watch that History TV 18, that's one channel there. Okay, so also while we are talking about this, let's just talk about some limitations as well of these UAVs. So these UAV systems, no, one limitation is that you have a restricted flight duration. That means a drone can fly maximum for maybe 45 minutes. Then you bring it down, you have another battery, so it will run for another 45 minutes. Some of them work only for 30 minutes. Very heavy drones will work only for 30 minutes and things like that. Some very tiny drones, they also work for 2 hours and things like that, but they cannot fly very high. So such restrictions are also there. some 20 to 60 minutes on an average, I would say. That is the battery cycle of these drones, unless you have multiple batteries. You bring it back, it has already captured a data set some 1 kilometer away. You bring it back and you send it that far again. So that much of battery is again going on. So all that is there. Besides that, there are also regulatory restrictions. Okay, these also must be considered. So many countries have very specific rules. Um, for example, you cannot fly the drone very high. So flight altitude is previously determined. So you cannot fly higher than that particular height. So such rules are also there, placed by different countries. So you have to be aware of it. Also, some of the areas there you don't have permission to utilize the airspace. For example, maybe near some airports or some strategic areas, some industrial estates and things like that. Some private properties as well. You won't have permission um, to fly there, capture data there. So you have to have some permissions and things like that. Also, whoever is operating this drone, they have to have some basic certification that is required for the kind of configuration that particular drone has. Okay. Besides that, you need to know how to utilize that data for extracting the information. You have collected the data, but then how to utilize it in order to get the information, derive the information that you require. It will require some skills. So a skill-based manpower should also be there. And because high resolution imageries will also capture a lot of space in your device, that also becomes one of the very, very important criteria for you to look into. But in spite of all this, you will see drones being very extensively utilized. More and more people are using it. And as maybe upcoming geospatial specialist, I would suggest that you also get a basic certification of flying a drone, um, get to understand how to process LiDAR data, get to understand how to process radar data that is captured from satellite. So satellite, sorry, not satellite, drone. The drones are not only capturing these photographic images like I showed you, know, all these what is that? All these pictures that we saw, that is of the coast. Okay, all these pictures. It's not just this kind of recreational photography that is being done. Okay, there is also thermal photography that is also done. So I hope I have some picture. Some, yes. So you see here, this is a solar field, solar panel field. So what you see is that these solar panels have a little higher temperature as compared to the surrounding areas. So identifying them becomes very easy. So at night, if an image is captured, you will see that the solar panels will show bright uh, color. So wherever there is a lot of dust that is covering the solar panels, you know that it needs to be cleared off. Otherwise, its efficiency will come down. You can also count how many solar panels are working. At night, if you don't see them lit, then you know that there is something wrong with them and things like that. This is a SAR imagery. I've shown this to you previously when we were talking about terrain analysis using this SAR data. It helps you in identifying which are the areas which are planar. For example, that water body, monotonous, it looks dark completely, almost similar DN value, pixel value. So that is a planar region. So besides that, you see other strips also. This is a oil refinery. So you see the channels that are dredged there along the channel and across the channel and things like that. You see where all there are vegetation also, some changes in the terrain. All this is because of SAR imagery, and this is not a satellite data. Okay, this is a drone imagery. Then similar you see here as well. Similar you see here as well. Then this as well you see. So this is, if you look at this particular shadow, some of you might say that it is some person who is lying down there, but no, this also, it's basically the shadow of this. So that you see here. This is yet another LiDAR image where you are also looking at the shadows. These were the areas where the laser beam did not reach. So you are looking at a side image, oblique looking sensor. So some of the satellites look straight down, some of them look sideways like this, or some of them look ahead like that at an angle rather than looking straight orthogonal. They look at an angle. So these sensors are you know mm, made in such a manner. So yes, I would really want you to consider uh, getting a drone pilot certification, at least a basic one, maybe just being certified to fly mm, a drone which is heavier than 250 grams. It's a basic certification, maybe some 15 days of course. Uh, Many people are teaching this in Bangalore. I personally don't have a certification. That's why I'm emphasizing on it that um, anybody who is looking for getting into this kind of surveying and having a skill added to their CV should definitely consider this. I can process the data, but I don't have a certification. I can fly it also, but then I don't have a certification to fly a heavier drone than that of 250. Lesser than 250, you don't need a license. That is also there, provided you are flying in areas that don't require any permission. But if I go for flying a drone, even a recreational photography kind of drone, somewhere in areas which is of strategic importance, then definitely I won't be able to do that. Nobody will be able to do it. Even a certified person will not be able to do it. So yes, that is it. But I would want you to stay back, and I'm sharing one feedback form with you. If any of you would want to share their feedback as to how you felt that this particular theory foundation course was taken up, whether you benefited from it. Uh, if you did, then how well you benefited from it. What are the other things that you would expect um, to be learning from us? If you have any query pertaining to Praveena research, or if you have any query pertaining to the course that you have attended, or any upcoming course, how you felt through this theory foundation course, you are most welcome to talk about it. You are also most welcome to drop a message about it. Tell us how you felt, whether you could complete watching all the sessions, or if you are still waiting to complete all the sessions, or anything like that. You'll hear me keep quiet. I'm sharing a feedback link with you. Tell you guys, fill up this particular feedback form, and we're putting a condition that those of you who give a feedback will receive their certificate, just so that we get to know how you felt through the class. Page. This is a feedback form. It's the same feedback form, but for today, from today onwards, whoever gives the feedback will be considered for giving a certificate, either a participation certificate or a post completion certificate. Please give us your feedback. That is most important for us. We will be spending maybe just a minute. We would love to hear from you. And if anybody would want to unmute themselves and tell us how you felt through the course, through the classes, most welcome.